Comparison between assembly and embedded C program. So assembly, and here is I have written the embedded C program. So first we will discuss here the ORG00H. So what is the meaning of ORG00H? ORG means origin and 00H means the memory location. The meaning is it is the directive and the program which is start from the first memory location which is mentioned along with the ORG. And over here in the embedded C, whereas in the embedded C main two bracket we can use. So that means program which is started over here and we can return the our statements below the main. So now, so here I have taken the one addition of two numbers program. So move r1 comma has 05h and move r2 comma has 06h. So what is the meaning of here? The 05h, move the content of immediately 05h into the registers r1. So again here move the content 06h directly into the registers r2. R2 they are called as a variable, or sometimes they are called as a registers r1 and r2 of the microcontroller. So here instead of the r1 and r2 you can you can use the any alphabet abc and unsigned integer abc, a b c, a. So here a is equal to 0x5. So 0x5, that means move the content 5 into the register into the variable e directly. B is equal to 0x6, 0x6. So move the 6 immediately into the b registers or b variable. So here move a comma r1. So here move the content of r1 into the accumulators, then add the accumulators comma r2. Here the particular instruction we have to follow here and we have to use. So register add a comma r2. This is the one instructions of the assembly language, and we have to follow same instructions forever when you want it. So r2 a comma r2. What is the meaning of this? Add the content of accumulators with the registers r2. But here c is equal to a plus b. We can directly write here in the assembly language programming c is equal to a plus b. Add the content of a with the b and store the result into the c. And here move r3 comma a. So we have in this assembly language the results is by default, and by default is stored into the registers a, that means accumulators. And here move the content of r3 comma a, that means move the content of assembly language, move the content of accumulators into the r3. In this embedded C, same thing we can write here printf x comma c, the print the content of c, that is the c is our results. So in the assembly language here end directive use, and in the embedded C programming here we have used the close curly bracket. They are called as a curly bracket. So here in this way we can write the program into this embedded C programming instead of the assembly language program. Why program 8051 in embedded C? So it is easier and less time consuming to write in embedded C than the assembly. C is easier to modify and update. You know that suppose whenever you write the programs in the embedded C, we require the ID, integrated development tool, just like to the compiler, assembler, editor, we can say that debugger, emulator, simulator, linker, and simulator. These are these tools we can easily modify, and best thing is that C programmings we can easily modify it with the help of the embedded C programming. So you can use the code available in the function library. Function libraries code we can use as per the requirements of the user. C code is portable to other microcontrollers with little or no modification. The code is very compatible for the different microcontrollers, especially 8051 microcontroller families. So are very compatible for the same programming. Suppose you have written the one program for the microcontroller 8089S52. So same program you can inbuild into the 89S52, 89S53, 89 we can say 89 C89 is 51 microcontroller also. So sometimes not required a modification, sometimes required a little bit modifications, but it is very easy. You can modify the C code in the embedded C. In the embedded C programming, we have to use the data types. So here data types, bit and bytes and value range. So sometimes we require the variables and the variable value. So here we can assign the variables with the help of the data types: bit, unsigned characters, signed characters, signed short, unsigned short, signed integer, unsigned integer, signed long, float, S bit and SFR. So these are the data types, and according to your requirements we can choose any one. Suppose bit, so this one bit, it is indicate that the value of that particular variables change 0 to 1. So this is the value range. Suppose we will take the one example of the unsigned characters. Unsigned characters, here the bit size is 8 bits and value range is 0 to 255. So here, so according to our results, according to that our results and our data, we have to choose any one data bytes. So here unsigned integer, it is the 16 bit and it is the 2 bytes. So here 0 to 65535, it is the max to max range. You can choose this one. Basically it is a frequently used unsigned integers, and here unsigned characters 0 to 55. So otherwise you can choose as per your requirements. S bit, SFR, that this is basically used for the special function registers. Size, it is 8 bit and here 0 to 255. So if you choose the proper data types, so then results will be get properly, and there is get good result. So here, so these are the data bytes, and you should know the value of each and every value range. So you can mark up this one: bit data bytes, value range is 0 to 1, sign into characters minus 128 to plus 127. So these are the range. This range you should know before using this database in your embedded C programming. So now how to use the data types in this embedded C programming. Let's see. Step for embedded C. How to write the program in embedded C. So these are the 7 steps you can follow for write the C language program. So step 1, the commands. Suppose write a embedded C program for addition of the two numbers. So you can write here the commands, addition of two numbers. So that is called the commands. Command may be anything, so you can write over here. Then step 2, preprocessor directives. You can use here the preprocessor directive, just like to the include has register 51.h, such kind of the thing you can write here as per your the microcontroller. Which microcontroller you can choose for, you will choose according to that preprocessor directive may be related. So step 3, port configuration. Suppose you require the ports, input port, output port, so you can configure the port over here after preprocessor directives. So step 4, here you can use the global variables. You know that numbers of type of the variables we are required for storage the data. So that data you can declare, so that data variables you can declare over, they call as a global variables. Global variables means, so this variable you can use in your entire programs anywhere. That is called the global variable. Now step 5, here main functions or core function. This is the main function. Here you can start the program. So this is the main platforms. Here you can write your entire program statement. So main functions or core function, here this is the curly bracket. So whenever you write the open curly bracket, then after that you can write your the program logic and the variable declarations. So step 6 and step 7, there is a variable declaration and program logic. You can have program logic, you know that addition of the two number, then you can use here the C is equal to a plus b, just like the, and after that you must be write here the close curly bracket. So this is the main programs, and you can follow this program whenever you start the assembly language. Not assembly language, we can say that the C language program. Next programs, write a 8051 C program to toggle all the bits of P1 continuously. Suppose port 1 there is we will use there 8 LEDs. 8 LED must be continuously toggle pattern, must be continuously on or off in form of toggles. So here for the statements we have to write the program here. The first the hash include register 51.s, it is a by default we have to use here. Then while main, after the while main we have to use the one condition, and you know that there is the for loop, and we have not write any condition in this loop, and just we have used there the two semicolon, is meaning that there is no any condition and condition is not satisfied forever, so that this loop is continuously execute as continuously execute continuously the programs will be we can say that work. So and after that this is the curly bracket, we have used the open curly bracket. Now then port 1 equal to 0x55h, is meaning that the port 1 load the port 1 by the value of the 55. The port 1 must be loaded by the 55. The 55 value is nothing but the 0 1 0 0 1 0 1 in this way. Now after that we have to load the port 1 by the value of the double A. Okay, so double A is nothing but 10 10 10 10. So in this way this is maintain the toggling patterns of the blinkings of LED, and all both the data is simultaneously, or we can say alternately, loaded into the port 1, and the port 1, suppose there is a LED will be blink in form of the toggling pattern. So this is the loop of the for loop, and this is the another closed loop curly bracket loop of the main while loop. So now here between these two 55 and double A, so between this we can add the delay. So for that we'll take the another program how to use the delay. So in this way this one program execute, and the LED will be blinking continuously or rapidly patterns because of for loop.